Hi, hello everyone. Good evening. This is your Ameer sir, Master Teacher of Physics at Vedantu, and welcome to another amazing session of Rapid Sprint 2.0. Let's not say amazing session because here we have to make it amazing. So I need your complete cooperation. You all have to be with me together, isn't it? So who all we have in the class? Hi Kaushika, how are you? Good evening. How are you doing? All good? Fine, great. What do you say? Hi Aditya, good evening. Good to see you here. And how are you all doing? Tell me that. Exam days, it's very fastly approaching, isn't it? But you don't have to worry anyway. I think you are doing your job, which means working hard for the exams, studying for it, so whatnot. And moreover, you are here in the classroom with Rapid Sprint 2.0, and we have completed almost all the topics, isn't it? So if you have looked at the schedule, we have completed the first part of 12th, and here we are with which topic we are going to discuss, everyone. Yes, we're going to discuss about the topic atoms today. So yes, Kaushika, hi, I'm doing so good, right? It was a bit busy day. Anyway, I'm doing fine. I'm doing so good. I'm so happy, and good to see you everyone here. What about you all? Like, tell me how's your revision plans going on? Is it all good? Yes, Kaushika is there. Yes, you got it right. The topic for today's session is atoms, which is a part of modern physics, right? Okay. One or two questions are very much probability is there for coming from the part of modern physics, and most of the time it is from atoms. You can see that. So that's why now today we have the topic of atoms, and let's discuss in detail of this particular topic of atoms. Okay. Pre-board, no worries. Okay, so if you are having, so let's get this topic very deep, which means let's go with the topic of atoms, and if a question pops up for your board exam from the topic of atoms, let's make sure that you are not going to get a wrong answer, and all the other topics are already being covered after this class. Please go and watch it. Okay, and yes, thank you so much. And if anyone is new to the classroom, isn't it, Aditya, are you new to the classroom? And if you haven't subscribed, move your cursor now itself and get subscribe to the channel and press on the bell icon, because I don't want any of you to miss any of the amazing videos which is happening here, right? Okay, so once you subscribe, you will get the notification from the channel whenever a classes happens. And regarding the Telegram group of Momentum with Vedantu, link is given. What's happening there? Yes, all the questions that we discuss here will be uploaded in the group prior to the session, so you can actually have a look at those questions before you pop up here in the classroom. One last thing regarding the crash course. So what is there in the JEE 2021 crash course by Vedantu? And we are making a very great sale also. Let's talk about crash course before we start with our sessions, right? Okay, now crash course, I think now you might be facing these problems. You wanted to cover all your theories, okay, but you don't know from where to start. You have a lot much of conceptual unclarities are there. So many doubts are not being cleared. You want to clear it. You wanted to do hell number of many number of problems, and you are not able to do that. You are not able to find time. You are not able to find proper questions. And moreover, after doing all these things, you actually want to analyze how much you have learned, which means by doing some mock test. So if you are looking for such a kind of a crash course which can solve all your problems, the best place for you to be here is in the Vedantu's fast track live crash course program, where at this moment we are providing a 30% discount. You simply have to apply the coupon code AMECC once you click on the link which is given in the description. Actually it costs 10,000. With a 30% discount you will be getting just for 7,000 rupees. This crash course with this amazing features, if you get it for 7,000, oh my god, if I was the person right at this point, I would have never thought twice. I would be here already. Anyway, wishing you best of luck. Here comes the very first question. Are you all ready for that? Yeah, sure. Make some special videos about how teacher take a Viva, please. Let's talk about it right now. Let's make the session so great and awesome. What do you say, Aditya? Are you ready for that? Are you ready for that? Kaushika is already ready. Others in the classroom, I'm not able to see anyone. Make the class so exciting. Where are you all? Okay, so I'm going to think that everyone is so lazy to type there, but still all are with me. And let's start with the question 1. Whatever answer you get before me, you can post it in the chat box and let me know whatever the answers are. Okay, yes, here we go. Very first question. the first line of Lyman series in hydrogen spectrum has a wavelength of 1220 Armstrong. Calculate the wavelength of the second member of the series. Okay, now you know about the hydrogen spectrum, right? Okay, now the Lyman series of hydrogen spectrum happens whenever an electron jumps from any higher level to the first level, which means let's say that this is the nucleus and these are the orbits around it. Now if an electron jumps from a higher energy state to a lower energy state, obviously energy is being released in the form of photons, right? Okay, and each photon released will be creating a spectral lines, and those collection of lines we call it as series, and the collection of those spectral lines which is produced because of the electron jumping from any higher energy level to the first or the ground state, which is n equal to 1, we call it as the Lyman series. And what is the formula for calculating the wavelength of all those Lyman series? That is equal to R, which is the Rydberg constant, into 1 by 1 square minus 1 by n square. So n corresponds to the number of the orbit from which the electron is jumping. So the wavelength value is given as 1 by 1220 for those okay, for the first line of Lyman series. So what is this first line of Lyman series? The first line of Lyman series happens whenever the electron jumps from n equal to 2 to n equal to 1, which means 1 by 1 square minus n will be equal to, it is jumping from 2, so that's equal to 4, which means this is equal to 3r by 4. So we got the first formula as what? 3r by 4 is equal to 1 divided by 1220. Question is not that. The question is actually about finding out the wavelength of the second member. Second member means if an electron jumps from this third orbit to the first orbit. So the wavelength value at that point of time is equal to r into 1 by 1 minus 1 by 3 square. It is jumping from where? From the third. So this is equal to r into 1 minus 1 by 9, that is equal to 8 divided by 9. So 1 by lambda is equal to r into 8 by 9. So let's substitute for r from here. What's the value for r? That's equal to 4 by 3 into 1220 into 8 by 9. So how much we're going to get? We are going to get almost a value for, this is 1 by lambda value, taking it ulta, you will get the option as C, which is 1012.5 Armstrong as our answer. Simple, isn't it? Simple. If you know this specific equation, just applying the values, and if you know the concept of Lyman series, yes, the problem is done. Any doubts? If you have, you can ask me now. Any doubts, anyone? Or simply you are like, okay sir, that's done, just move to the next. Are you that chill? Okay, then if you all are ready and if you have no doubts, why we have to stuck with the same question, it's time for the next. Good. Now, the radius of the innermost electron orbit of a hydrogen atom is 5.3 into 10 power minus 11. What is the radius of the orbit in the second excited state? Now, who's going to tell me the formula to find out? Yes, the radius of the nth orbit of an hydrogen atom. R is equal to n square r naught, where r naught is considered to be, or it is a constant which we call it as the Bohr radius, with a value of 1.5 into 10 power minus 11 almost. Find r naught. Now it is given that the radius of the innermost electron orbit, which is the innermost when the electron is present on the ground state or n equal to 1. So the radius is given as 5.3 into 10 power minus 11 when n equal to 1. So 1 square into r naught, right? So from here we are actually getting the value of r naught here, which is 5.3 into 10 power minus 11. That's not the question. Kaushik already gave the answer 1012.5. Didn't see that? Very good. Okay, so what is it? Once again you are asking me to repeat the question, right? Okay, so the radius, this is nucleus, first orbit, second orbit, third orbit. Let's say this is the nth orbit. Okay, the radius of this nth orbit Rn is given as n square into r naught, where n is the orbital number. So here it is given that the innermost orbit, which is the innermost orbit where orbital number is equal to 1. So if the orbital number is equal to 1, that orbit is having a radius of 5.3 into 10 power minus 11. This is what is given, right? Simple. Okay, so I just have applied the values, whatever it is given in the question. Now, let's see what is our real question. What is it? The radius of orbit in the second excited state. So, radius of the orbit for n equal to 2 will be equal to n equal to what? 2 square into r naught, that is 4 into 5.3 into 10 power minus 11. How much you're going to get? 5 4s are 20 into 10 power minus 11, or 2 point something into 10 power minus 10. So it's option A. Understood? Hi Kaushika, hi Prasanna, hi Mega Killen. So we have so many new students in the classroom. Hi everyone. How are you all doing? So join the class. Okay. Okay, Prasanna, I already told you we have no surety of the theoretical classes when it is going to happen. Once it is happening, I think you all have subscribed to the channel, right? Everyone here have subscribed to the channel, I suppose. So we're going to start it soon, so don't worry about it. And once we start, okay, the notifications will be given to you. So I have no idea what is the date and all. Okay, hi, good evening, Sabu. So good to see you back again. And here we are with another question. Ready? Everyone, where are you all? Come on, coming back. The ionization potential of hydrogen atom is what? Minus 13.6 electron volt. What do you mean by the ionization potential? Now, let's have a look at it. So, this is our nucleus, first orbit, second orbit, third orbit. Okay. The ionization potential means the amount of energy that has to be given to the electron in an orbit. So, in a hydrogen atom, the electron is present in the ground state, and for this electron which is present in the ground state, the amount of energy that has to be given so that we can take it away from the attraction of the nucleus is 13.6. That is what you mean by ionization. To ionize, okay, to remove the electron. How much is the energy? 13.6. So if 13.6 has to be given, what will be its current energy? Its current energy will be equal to minus 13.6. So the energy of the electron in the first orbit of this hydrogen atom is equal to minus 13.6. That's what it tells you. I hope you got it, right? Okay. Next, an electron in the ground state of hydrogen atom absorbs, right? Okay, a photon of energy 12.75 electron volt. So this electron, which is having an energy of minus 13.6, is absorbing actually 12.75 energy. So what will be its net energy? It is minus 13.6 plus 12.75. This will be 0.85 electron volt with a negative sign, which means the energy is still negative, which means it hasn't gone away from the nucleus, still it is in some orbit, right? So let's find out in which orbit currently is this particular electron now after absorbing an energy of 12.75. Isn't that what we have to understand? Yes. So the current energy is negative of 0.85. We know that the energy of the nth orbit is given by, what's the formula? Minus 13.6 by n square, right? So minus 13.n square, the energy of an electron in the end orbit is equal to minus 0.85. So n square is equal to negatives cancel, 13.6 divided by 0.85, you will get it as 16, or n value is equal to 4. Which means after absorbing an energy of 12.75, it will be exciting. You know that if the electron absorbs energy, what happens? It will be moving to the higher energy level, and it will be reaching now, according to the formula, to the fourth orbit. Let's say it is coming back to the initial ground state. How many spectral lines are possible? Okay. So listen, the spectral lines correspond to each and every frequency, okay, and when the spectral lines will be visible? Whenever an electron makes a jump from higher energy state to a lower energy state, during which a photon is being emitted. Now, whenever an electron is in the fourth orbit, first orbit, second orbit, third orbit and fourth orbit, right, what are the different methods of these electrons to come back to the ground state? Let's understand. It can directly come to the first orbit. So one spectral line or one photon, okay. It can come to the second and then it can move to the first like this, or it can move to the third like that, okay. From the third it can move to the second, and from second it can move to the one. Or what happens? those electrons which are in the third, it can directly move to the first. So there are 6 different ways by which it can move to the first. So during this time, 6 photons are emitted. 6 photons will be corresponding to 6 spectral lines. So during the transition, it will be providing how many spectral lines? 6. Okay, Vijay, is it clear? I hope you all are here. Let's learn the topic atoms. Let's learn the topic Akilan, Vijay, Sabu. Here anyway I am explaining all the theory related for doing this problem. Okay, so I hope you all are with me understanding all these concepts, but instead you are talking in the class. Where are your commitment for the class? Where are you all? Come join the class, make it good, make it active, make it energetic. I want the class to be super good. Okay, so give me the answer whenever a question is there in front of your screen. All good, fine. Okay, moving on. Calculate, listen everyone. Okay, so Kaushika, very good. Others, okay, so ready? Any doubts from the previous question? No, yes, no, what it is? Okay, I'm not able to find any answers. Okay, so I'm going to think that everything is clear. Nobody is left with any single doubt. So that means directly we are moving for the next. So here it comes. Calculate the energy released when an electron makes a transition from an excited energy level to the ground state of the hydrogen-like atom. Given that excited energy and ground state are this much, so how much energy will be released? So the energy possessed by the body whenever it is at some excited state is equal to how much? 25 electron volt. Now this electron is moving from this high energy state to a low energy state to become minus 16 electron volt, right? Which means it is losing its energy from 25 to minus 16. So how much energy is released? Whatever is the difference in the energy between that electron currently, that itself will be equivalent to the amount of energy that is being released. Nothing to talk about it, right? So what is its difference? 25 minus 16, that is equal to 41 electron volt. Yes or no? So the answer is option D. Understood? So the simple way of doing this problem is the energy release is equivalent to the energy difference in the initial and the final state. That's all. Got it? Yes, Vijay, Agilan, Kaushik, Sabu, where are you all? Make the class so active, make the chat so active. Okay, very good. So which one is n equal to 3? Which answer you're giving, Kaushika? Actually, I'm confused actually. N equal to 4, I think you already got this. Okay, yes, moving on. What is it? The ground state energy of an hydrogen atom is minus 13.6. If an electron makes a transition from a energy level with energy of 0.85 to minus 3.6, to which series of hydrogen spectrum does the wavelength belong? Okay, so we have to see from which level to which level it is jumping. So initially it is having an energy of minus 0.85. We know that energy of an electron or energy of an nth orbit is equal to minus 13.6 divided by n square. So initially it is having an energy of minus 0.85. So energy of that orbit initially is equal to minus 0.85. Finding out the value for n square, 13.6 by 0.85, 16. Initially n is equal to 4. Okay. Kaushika, great, all good, very fine. So you got the value for n equal to 4 here. Initially it was an orbit of 4. Now finally it is coming to a level where the energy is minus 3.6. So how will you find out the orbital number? We know that energy is equal to minus 13.6 by n square. So it has been found that the energy of the current orbit is equal to minus 3.6. Okay. So from here you will get the value for n square as 4, right, and n will be equal to 2. Actually it is jumping from where to where? From 4 to 2. So if you are jumping finally to 2, to to which spectral series it will be named under. It will be named under, yes, Balmer series, which is the visible light series. Okay, good. Understood? No doubts. You just have to apply all these things. So I hope Lyman series you all know. Some extra information. Lyman series corresponds to UV lights. Balmer visible. Passion series, bracket series and fun series corresponds to infrared. Okay. If it comes to n equal to 1, it is Lyman. If it comes to n equal to 2 finally, it is Balmer. N equal to 3, 4 and 5, it corresponds to UV, which is passion, bracket and fun respectively. Okay, good. Yes, Sabu, very good, very good. Someone here is also there to give me the answer. Good. So it is Balmer series. Option B, it is not D. B Balmer, not fun series. Okay, you're talking about the 41 electron volt part. Okay, good. So next, the energy required to ionize a hydrogen-like ion in its ground state is 9 Rydberg. Right? What is the wavelength for the radius emitted when the electron in this ion jumps from the second excited state to the ground state? So an electron is in the ground state for an hydrogen-like atom, not hydrogen atom, hydrogen-like atom. Hydrogen-like atoms are those atoms where it has one electron just like an hydrogen atom. Okay, fine. Now it is given that the energy of an electron in the first orbit of this particular hydrogen-like atom is equal to how much? 9 Rydberg. R corresponds to Rydberg. So 9 R is the value, and always the energy associated with it is negative. We know that. Now how can you find out the energy associated with the nth orbit? That will be equal to energy associated with the first orbit by n square. We know the rule, right? Okay, now that is done. So what is happening to this particular electron? Yes, the electron is moving, is jumping from the second excited state. This is ground state. First excited, second excited. Second excited corresponds to n equal to 3, right? So it is jumping from 3 to 1. What is the wavelength associated? So first let us find out, when it makes a jump from n equal to 3 to n equal to 1, what is the energy release? For that we have to find out energy of this third orbit. So that's equal to minus 9R by 3 square, that's 9, that is equal to minus R. Okay, so how will you find out the energy release for the photon when an electron makes a transition from higher energy state to a lower energies? That is equivalent to the energy difference between the orbits, isn't it? Isn't it equivalent to the energy difference between the orbits? Yes, it is. So how will you calculate delta E? Higher energy minus lower energy. Lower energy was minus 9R. So this corresponds to 8R. Okay. So delta E is equal to 8R. So this is the energy of the photon. How will you write energy of the photon? H nu is equal to 8R. Nu is equal to C by lambda is equal to 8R. You got the value, right? You got the value, isn't it? Yes, you want to find out this lambda. Lambda is equal to H. What is H? Planck's constant, 6.6 into 10 power minus 34. C is 3 into 10 power 8. R is equal to 1.07 into 10 power 7. Right? Okay, doing the math. Finally converting to nanometer. What's the answer you're going to get? Yes, 11.4 nanometers. Good, Kaushika. Wow, you gave the answer already so long before. That's great. That's good actually. Okay, hi Harjinur Kaur. Wow, that's a pretty unique name. Never heard such a name before. Good to see you here. Very good. Yes, very good, Kaushika. Yes, I have seen that. Good, keep it up. Now, 2 statements are given, so you have to check which all are correct, whether the first statement is actually explaining the second statement and all those stuff. So let's read each and every statement. According to classical theory, the proposed path of an electron in Rutherford atom model is parabolic. No, according to Rutherford model, the electrons are revolving around the nucleus in circular path. So first statement is false. Which option says that? Yes, it's false. And electromagnetic theory, you have an accelerated particle, which means that here the particle is electron. It is a charged particle which is accelerating. It emits radiation, electromagnetic radiation. Yes, that's true. We have learned in EM waves. What else we need? Yes, we got the answer as option D. So we have discussed so many problems, and through all these problems we try to cover maximum theory of this particular chapter also. Is it clear to everyone? Hi Pratmesh. So if you have missed the class, okay, please do watch the replay. It will be available in the YouTube, okay, it will be streamed. So you have to watch it. We have done so many amazing questions, let's say. So I hope you all got it. Everyone is happy regarding the session, right? So what do you have to do? For everything what happened here, you just have to do very small chotu things which you can sit on your seat and can do it. If you love the session, right, okay, so please like it, because your like will let me know that whatever I'm doing it over here, okay, you all are appreciating, you all are understanding, and it is helping you a lot. Okay, it will actually motivate us, right, in doing more and more such videos. Okay, it is going to help you a lot in your further future also. Share it with your friends, ask your friends also to come and join. Okay, they are also gonna get benefited just like you. And last thing, subscription. I think I don't have to tell you all the time, because you have to do that. Why? You just have to do it because you will get all the notifications from the channel. And let me tell you, me and Garang sir are doing many videos, live classes and recorded version, so that your learning process is gonna be so much easier. Okay, so thank you so much. Like, yeah, Pratmesh, wow, that's great, hats off, good, thank you so much. So we're gonna meet in the next class. Till then, bye bye everyone, take care and good night.